The binary analysis tool helps make it easier and cheaper to do compliance and due diligence around FOSS technologies. It works as a modular framework for auditing the contents of compiled software. The tool reads binary code and automatically compares it to source code, complementing manual analysis techniques. Today, it can read binary code across multiple architectures, detecting whole programs or fragments of programs inside that code. The feature list includes the ability to extract file systems, identify the version and configuration of BusyBox, check for the Linux kernel, do brute force scanning of firmware, and even feed known information through a knowledge base for higher fidelity analysis. All of these techniques are based on symbol and string table comparisons, not reverse engineering. Let's have a look at the tool in action. We expect it to be used to scan firmware to help identify FOSS components and configurations. Let's do that. First of all, we'll ask the tool to have a look at a generic firmware. It will attempt to open the firmware and find components inside. This is a relatively quick scan. Alright, it's found the Red Boot bootloader, the Linux kernel 2.6.15, and various things inside a SquashFS file system, including BusyBox. There's quite a lot of information already, including details about kernel modules with no licensing information, statically linked binaries, and other GPL licensed tools. For higher fidelity scanning, we also need to look for things like the configuration used to compile binary code. Let's look for the configuration used to make BusyBox and try to work out if the configuration used to make the binary has been included with the source code release. Alright, this is the configuration that the tool thinks was used to make the BusyBox binary. Now, we're going to compare that with the configuration we have in source code. If they match, everything is probably in order. If they don't, the tool will let us know that there might be a problem. Let's see what the analysis says. Okay, it seems to have found at least one error regarding the source configuration and the configuration it guesses that the binary used. Probably that needs to be addressed before a product is shipped. Going into more fidelity, this tool can extract a lot of strings in the Linux kernel and try to work out how the Linux kernel was put together. That can help us work out if the Linux kernel source provided with the binary is complete and correct. The initial analysis contains a lot of information. This information includes some generic strings and quite a few strings that have a unique match. Right now, there's probably too much information, and we need to reduce false positives so we get a more accurate picture of what was actually included in the kernel. To do that, we can specify the architecture used, in this case, MIPS. The information is still substantial, but reduced to a more manageable level. The false positives have been reduced too, so we're getting a better match and a better idea of what was used. We can use this information to do things like get the configuration used to make the kernel. That will help us do the same type of analysis we did with BusyBox to work out if the source code is actually complete. These techniques can help make it easier and safer to release code and clean up any problems introduced during the development cycle. The cost of the binary analysis tool is zero. It's released under the Apache license, so absolutely everyone can download and apply it, no matter what their circumstances. It's not perfect and doesn't replace a dedicated compliance engineer, and it requires integration into existing workflow to be useful. However, when correctly applied, It has the potential to reduce costs and increase productivity around fast due diligence. This is a project that is free software, and that means everyone can use, study, share, and improve it. You can get involved at www.binaryanalysis.org. The tool was developed by Lewis Consulting and OpenDawn. It has been sponsored by a Nelnet Foundation in the Netherlands, and it has received support from the Linux Foundation. Thanks for watching. Get more information at www.binaryanalysis.org or email info@binaryanalysis.org.